Good morning, everyone. Dr. Jain.
Good morning.
Good morning. Shall we start?
Yeah, sure.
So, good morning, everyone. I welcome you all on this 2022 fourth International Conference on Soft Computing and its Engineering Applications. And I welcome Dr. Sonal Jain. She is a professor at Sardar Patel University, Vidyanagar. Her area of research is AI in broad and NLP in particular, then information retrieval and technology in education. I welcome you, ma'am, on this first technical session. In this technical session, we have 4 papers, and today we have total 8 technical session, 2 keynotes speech and 2 invited talk. So I think we can start now the first technical session. So I made you the presenter, ma'am, and I think you must have this schedule. Otherwise, I can.
I do have it with me.
So first paper is with a paper ID 226. So author of paper ID 226, are you there?
Each presenter should restrict themselves to 10 minutes.
10 minutes for presentation and 4 to 5 minutes for question answer. Paper ID 226, authors, are you there? Okay, welcome. So shall we play the pre-recorded video or are you going to present your paper online? Your microphone is muted. Your microphone is muted. Audio is not coming to us.
No, still you're not audible.
Just a minute. Just a minute, I make you the presenter. Yes, Miss Joy. Now you're the presenter. You can unmute your microphone and you can speak. So whether We cannot hear you. Your audio is not coming.
Can you type in chat box if any issue you are facing?
Shall I play your pre-recorded video, Dr. Joy?
I think now she is freezed as well. Any other team member?
Paper ID 212. Author of paper ID 212. Are you there? Yes, Miss Joy. Can you hear us? Your audio is not coming.
She is muted her speaker. See the symbol.
You can unmute your speaker, ma'am. Okay, can you present after the one paper, Miss Joy? Okay, we can take other paper, paper ID 212 with Dr. Kasim. Are you there? So I make you the presenter.
Yes, I'm here.
Just a minute. You are the presenter, so you can start your presentation.
Okay, let me share my screen.
Yes, we can see yours.
All right. So my paper is titled One True Pairing, Evaluating Effective Language Pairings for Fake News Detection Employing Zero-Shot Cross-Lingual Transfer. So let's get into it. In the recent years, we've all heard about the scourge of fake news. Particularly, this is a result of the growth in online content, which has enabled greater access to knowledge than ever before, but has also resulted in an increase in misinformation. One type of misinformation that has come to the fore is what's called fake news. And social media platforms and others that are trying to combat this scourge are relying more and more on machine learning algorithms for fake news detection. But these algorithms rely on labeled training data, which brings us to a problem when looking at fake news detection in different languages. Of the world's 7,000 languages, only 20 are considered high resource languages, in that there's sufficient training data available in these languages for machine learning tasks. The remaining languages, and these include languages like Arabic, Hindi, Thai, that are spoken by millions of people, are considered low resource languages. So that brings us to what are called large language models. These are models like BERT or GPT-3 that are trained on massive amounts of data and are used for common natural language understanding tasks. A subset of these large language models are what are called multilingual large language models. And these are models trained on monolingual training data or data from parallel text for multiple languages. And what these models do is that they use a shared vector space for different languages, so that the same word in different languages will have similar embedding representation. So for example, chat in French and cat in English will have similar embedding representations. In my study, I specifically utilize XLMR and multilingual BERT or MBERT for fake news detection. XLMR is trained on over 100 languages, and MBERT is trained on 104 languages. So the problem that I was trying to research in my paper is that given the limited label training data available in low resource languages, can multilingual language models such as MBERT and XLMR be utilized to train a model on full text fake news detection in one language? So train in one language and use that to detect full text fake news in another language. So some of the related work in this area has been done by Oshikawa et al., who highlight the unavailability of data sets for fake news detection, especially full text articles. Du et al. Did a study where they used cross-lingual COVID-19 fake news detection tasks to detect fake news using MBERT with models trained in English on Chinese data. They found that this was ineffective in cross-lingual fake news detection. Bhatia et al. Did another study where they used multilingual language models successfully in detecting hate news and offensive speech across English, Hindi, and Marathi. But what they did was they only used tweets, which are small text, as opposed to full text articles. So let's talk about the data sets. Fortunately, monolingual data sets were made available very generously by researchers, and I used the data sets in Bengali, English, Spanish, Filipino, and Urdu. These data sets came from different domains. And so, for example, English data set was mostly on politics, while the Urdu data set was mostly business, sports, or entertainment news. There were also script differences. The Bengali data set was in Bengali script, Urdu was in Arabic script, and the remaining were in the Latin script. Another thing is that all the other data sets were captured from online news, whether real news sites or sites that are known for having fake news. But the Urdu data set was generated by journalists mimicking, writing fake news versions of real articles. In terms of my processing architecture, just a quick overview. So all data sets were munged and normalized. And then during feature extraction, the data sets were processed. Each article was sentence tokenized, and then they were, depending on the experiment being performed, encoded via XLMR or MBERT. So each article was taken and encoded into a one-row vector representation. Then these one-row vectors were put through classification training through either SVM or neural network, depending on the experiment being performed. And this was used to generate a monolingual model. Then I performed two types of classification, monolingual and crosslingual. And for monolingual, it was using, model trained in English on an English language dataset. But for crosslingual, it was taking that same monolingual model in English and testing it on every other data set, Spanish, Bengali, Urdu. And this was done for all the languages. So first to look at the monolingual results so that we have a basis of comparing the cross-lingual results. You can see in the output that the F1 scores for Bengali were the highest. Bengali was not only the largest data set, but it was also the most imbalanced data set. We also see that XLMR outperformed MBERT and that the neural network algorithm outperformed the SVM algorithm. Another thing to note is that the Urdu language classifier had the worst performance in the monolingual results. Now we come to the cross-lingual results. What we find is complete opposite, where the Urdu model actually had the best performance across the different languages. What we also found was that a classifier trained in one language that performs well against one language doesn't necessarily mean that the reverse is true. So Bengali classifier in English language had an F1 of 0.68, but the reverse only resulted in 0.03. Also, in a departure from the monolingual result, the MBERT hidden neural network outperformed other classification and LLM models. So what were some of the findings? One was that the importance of language transfer. What we found was that language transfer, due to shared language ancestry and history, was really important for language pair results. So for example, the Filipino classifier performed well against the Spanish data set, while the Bengali and Urdu classifiers performed well against English. An English classifier had the worst performance across all the other data sets, but it had a better performance against the Spanish language data sets. Also, what we found was that the monolingual models trained in Urdu and Bengali, which are low resource languages, outperformed high resource language models, which was unexpected. In terms of other conclusions, so what I performed was zero-shot cross-lingual transfer, which demonstrates promise in fake news detection. But as I mentioned earlier, the domains of these data sets differed widely. And so in the future, there's room for two-shot or multi-shot cross-lingual transfer. That's actually what my current research is focused on, where I am trying to perform domain adaptation to minimize the domain differences between these language and use multi-shot language transfer to improve the results that you've just seen. Another important finding was that full text articles contain a lot of information, and some of the information is real and some of it fake. So what would look like a very naive approach of averaging all the articles into just one row vector, perhaps would lose some of that nuance, actually was not the case. It was quite good at detecting fake news. And finally, another important finding that has been echoed in other similar research papers is that low resource models showed great success in detecting fake news in other low resource languages. And that's a real opportunity area for further research because in the main, what we're trying to address, or what I was trying to address in this research, is how to utilize how to better detect fake news in low resource languages. And it appears that low resource languages are actually the best at detecting fake news in other low resource languages. So that was, here are the references, and that was the end of my presentation. I'd be happy to take any questions.
Any questions from the audience? Anyone has any question?
Yes, audience is having any questions? Sorry, I was off. Yeah. Sir, B.K. Mishra ji wants
Yes,
to.
Dr. Mishra, just a minute.
Hello.
Yes.
Hello, sir. I am B.K. Mishra and I am also presenter. But my session is in 2 o'clock. But I have one query that how you build corpus for this thing. Samara Qasim.
Dr. Mishra, do you have any question on this presentation? If you have a query, then you can call me.
Yes, I have query. That's why I am asking. My
Right now.
question to Samara Qasim that for building this thing, you have built some corpus. So what is the criteria for building this corpus?
So the corpus that I've built was gathered from data sets that were created by other researchers. They use those data sets for monolingual fake news detection. So for example, the Bengali data set was generated for research done on detecting fake news in Bengali. What I did was gather the different data sets from the different languages and normalize them across so that they had the same classification label, for example, for fake versus real news, and just process them and normalize them. And develop this corpus, but the original data sets were very generously made publicly available by other researchers who used them for their own monolingual research. I just applied it to cross-lingual fake news detection.
Okay.
May I?
Yes.
Yes, Dr. Kasim, you mentioned that you have utilized Bengali language data set and that has been giving you the best performance. However, the data is imbalanced, quite imbalanced as mentioned by you. So, what is your input to that? Even if it is imbalanced but still giving better results? So, any interpretations on that?
Yeah, so the best results that it gave was in the uh, monolingual test. So it had the highest results in the monolingual test, and that's partly because it was so imbalanced that it was just in terms of the training and the testing data. But where I felt that it wasn't as important for it to be for that it was imbalanced was when I was using it for cross-lingual fake news detection. So here you have a data set that's trained on the Bengali language, right? And even though it's that's an imbalanced data set, it's being used to detect fake news in Urdu or in English. And so in that sense, it actually benefited from seeing so many different uh, uh, real news articles because it was more imbalanced in favor of real news. I think it benefited from seeing so many real news articles when it came time to detect fake news in other languages, because the fake news has a similar flavor to it, where, for example, the articles tend to be shorter. They tend to use sort of easier words, easier vocabulary. They may have more errors. And I think it picked up on that due to the training. So I think it was less problematic to use an imbalanced data set for the cross-lingual aspect of it.
Thank you. So we can take next presenter.
Yes. Anyone else has any question?
Yes, sir.
Yes. You may.
Yes, Samra, ma'am, you present a very good topic, but I have a one question because I work on this fake news from the last 1 year. Just you said that you are considering that the language which is used in the news, based on that you can identify which news is real and which news is the fake. What are the other parameters that data set is considered to differentiate that this particular news is a real news or the particular news is the fake news? So can you just mention, or can you just list the parameter based on that we can classify between fake news and real news? Thank you.
Thank you for that question. So what I was relying on was the label data that I gathered that I gathered from the different data sets. So like I mentioned, I relied on data sets that have been generated by other researchers for monolingual fake news detection. And so they were already labeled, and I just used the labels that they created, and I did zero-shot cross-lingual transfer, so I didn't do any additional sort of parsing for parameters. The main problem I was trying to address is how effective are the large language models in making up for the fact that the models are trained and tested on different languages.
Okay, thank you.
Dr. Jain, one more attendee is asking for having some question.
It would be better if they can actually type the questions in the chat box and Samra answers it because it is 10:23.
Yes.
It is our
Miss
first
Maria, can
session,
you?
so I don't think we should delay it.
Yes. Okay. So now, thank you very much, Dr. Kasim. Now next presenter, that is this Miss Joy. Are you now there? Can you make your speaker microphone unmute?
Yes, I think. Can you hear me now?
Yes, we can have we can hear you now.
I'm sorry for the inconvenience. I just uploaded my software. Can you
No.
make me presenter so I can share my screen?
You are presenter. You can start your PPT and you can share your screen.
But from my side, I think I cannot share my screen now. Maybe because I use a MacBook.
Just a minute. Okay, now you are.
Yeah, I can see that now. Thank you.
Yes, we can see your screen.
Hello, everyone. Can you hear it?
Yes, we can hear you.
Okay, thank you. My name is Chen Ruzhou. I'm from the Nanjing University of Science and Technology. Today, I'm going to present my paper, RHINE, towards a scientific, rigorous, interpretable artificial immune system for intrusion detection. The cybersecurity is of serious urgent. An artificial immune system is a bio-inspired algorithm. It is inspired from a human immune system, which uses negative selection mechanism to select any virus, bacteria, and abnormal cells from healthy ones. The ultimate goal of cyber intrusion detection is to build artificial immune system which can tell any traffic that is abnormal from the healthy one. The performance of artificial immune system depends entirely on the negative selection rule, which can identify benign traffic from the abnormal ones. However, with the population of quick protocol, all the package header informations are concealed. Even the IP addresses are scrambled. Traditional intrusion detection rules cannot be used anymore. In that case, machine learning is the only solution in times of quick, which means we can only guess. However, current popular machine learning methods are problematic. They are black boxes. They cannot explain their decisions. In domain of great importance like cybersecurity, decisions has to be explained and supervised by human beings. Here is a famous example of neural network and deep learning models. A couple years ago, a news report that deep learning can tell wolves from huskies with precision as high as 98%. And when explainable AI technology came out, people explained that model, wondering what had it learned. It turned out that the model did not learn anything about wolves or huskies. It can only detect snow, because all the photos of wolves in the training data, they are in the snow. All the machine learned that is that whenever there is snow, it is wolf, otherwise it's husky. Numerous method has been proposed to explain machine learning models. They can roughly be divided into two groups. One is rigorous explainable AIs, the other a heuristic method. Rigorous explainable AI methods use logic inference. They transform the models into Boolean expressions and transform the explainable task into theorem-proving problems. And thus they can provide sufficient and formal explanations to the model's decisions.
ठीक है रखो
Heuristic methods are different.
ब्लूटूथ ऑन
There are many
ब्लूटूथ
kinds
ऑन
of
ही नहीं हो
for heuristic explainable AI. Some use simpler models and that can provide approximate decisions and use that simpler model as explanation for the complex one. Some use controlled variables to get a rough idea of which feature is responsible for a certain kind of decision. All the heuristic explainable AI methods can only provide approximate explanations. They cannot provide logically sufficient reasons. Several work has been committed to explain models trained for intrusion detection. Macromallis tries to explain malicious black box Android malware detection on any type of models. This work uses a gradient-based approach to identify the most influential features. It also enables use of nonlinear models to potentially increase the accuracy without sacrificing the interpretability of decisions. In our humble knowledge, almost all the state-of-the-art methodologies of XAI in intrusion detection are heuristic or simply direct shallow interpretations provided by tree-based models. However, many researchers believe that the direct interpretation provided by decision tree model is shallow and redundancy. Thus, it's not necessarily the prime implicant in interpretations, which means it is not rigorous reason. Rigorous explanations are guaranteed to represent exactly the same behavior of the model, while heuristic explainable AI methods provide only the approximations of the real model. In rigorous explainable AI, a model is translated into a Boolean function, which can be represented by a propositional Boolean formula. Prime implicants of the Boolean formula are used to give rigorous explanations of the model. Explanations given using prime implicants are also called sufficient reasons. A sufficient reason or the prime implicant explanation is also the minimum explanation. The major difference between sufficient reason and a prime implicant is that the sufficient reason discloses the reasons of a certain instance, while the prime implicant illustrates the essential characteristics of the whole model. Sufficient reason explains the root cause of the decision, for an instance, in terms of the prime implicants involved. The decision will stay unchanged no matter how the other characters change. Please be noted that a decision may have multiple sufficient reasons and sometimes many. The Queen-McCluskey algorithm, or the tabular method, is used in this paper to calculate the prime implicant of a Boolean formula. The architecture of a proposed rigorous explainable AI-driven intrusion detection system, which named RING, is shown in this figure. First, traffic flows are collected into CIC flow meter, which can calculate the statistical information from the traffic flows. And then various machine learning models have been used to train and test on these flows. The model with the best performance is selected and been translated into Boolean formula. And then prime implicants of this Boolean formula are calculated and interpreted into the rules for the whitelist of benign traffic. The rules are then used for negative selection process in the artificial immune system. The whole process formed a closed circle for automatic informed machine learning. Models with discrete features can be transformed into Boolean expressions with atom variables, and these Boolean features can be immediately represented as Boolean circuit. However, most of the models used in intrusion detection have continuous features. Adnan Darwich from UCLA proposed a mapping method to map the continuous feature into discrete ones. We further enhanced this method and proposed the map and merge method, namely M&M, which can further simplify the Boolean formula with the merge process. Take the decision tree in the figure A, for example. The solid lines represent if the node is true, while the dashed line represents false. Based on each decision node, features with continuous values can be discreted into several variables. Each represents an interval divided by the decision node. In the end, the knowledge base represented by the decision tree can be simplified into x1 and y1 or x2. Discrete features get from the map process may often contain potentially a large number of redundancy, as the number of Boolean formulas is 2 to n, while n is the number of discrete features. Due to combination explosion, directly transformed discrete features into Boolean circuits may experience a huge waste of computing and storage. Thus, the merge process is proposed, used in algorithm 1, used in Ring. For example, let the knowledge base be the delta, which is x1 or x2, and y1 or x1 or x2 and z2, to be the Boolean formula of a model after map process. According to algorithm 1, the x1 or x2 fits the requirement of the merge rule. Thus, the model can be simplified into the x1 new and y1 or x1 new and z2. We evaluated our system with real-life data. The model to be interpreted is selected from our previous work. We have evaluated 8 kinds of common machine learning models on 11 different kinds of real-life intrusion data. The decision tree model has the best performance in both accuracy and time expenses when detecting the known intrusions. The area under the curve is almost 1. We apply M&M method to transform the continuous feature into discretized one. As shown in the figure, the 14 continuous features are transformed into 37 discrete variables. Thus, based on their features, each instance can be mapped into a 37-bit binary string, as shown in the figure. After discretizing the model into Boolean formulas using M&M, 41 prime implications are calculated with Green-Markowski algorithm. The prime implicant represented in many terms are shown in this table, in which a dashed line means a don't care. The behavior of the benign traffic detection of decision tree model can be rigorously interpreted as a TOR1 or TOR2 until TOR141. These prime implicants of the model works as an antibody in the artificial immune system, which are the rules for the negative selection algorithm. We present 5 examples of prime implicant explanations of real-life benign traffic instance. It is as shown in this table. The original features, the discretized features, the Boolean expression for each instance are presented in detail. The reason for why it is classified as benign is provided and marked in red in its Boolean formula. By the prime implicant that it is used to make the decision, the reason is sufficient and rigorous to explain the decision. For example, in flow instance 1, its Boolean expression is shown in this binary string below. After feature discretizing and mapping using M&M, it matched with the prime implicant's TOR41, which means that if the flow's Boolean expression start with 001 and end with 10, no matter what the value is for the other bit, it is a benign flow. With the feature discretizing mapping method, prime implicants tool can be interpreted as, in natural language, if the flow's forward package length minimum is larger than 110.5 and forward segment size average is smaller than 486, then it is benign. Thus, the model decides that the flow is benign. The whole decision process and interpretation is formal and rigorous, and the explanation is sufficient. This is my presentation. Thank you very much for your listening. I'll take any questions now.
Hello.
Hello.
Am I audible? Hello.
Yes. Can you hear me?
Yeah.
Yes, we can hear you. Dr. Jain and Ms. Joy.
Yeah. Someone from audience has already raised hand. Mr. Anand.
Hello, ma'am. Hello.
Yes, you may ask.
Yeah, sir, am I audible? Sir, actually, the presentation was not visible on that time.
Right.
That was the confusion.
Okay, no problem.
Dharmesh. Mr. Dharmesh, would you like to ask something?
Yes, madam. Good morning. I have also same question. We cannot able to see the presentation.
Yes.
There was a technical glitch.
Acha.
But,
She shared the screen, but she has not shown us the presentation. No problem. Anyone has any question? Okay, Ms. Joy. Dr. Jain?
no, thank you, Dr. Rao.
Okay.
Hey, thank you.
Thank you very much. So next paper is 206. Just author of paper ID 206. Are you there? Okay, let me play his pre-recorded video.
A very good day to one and all.
The screen is not being shared.
Just a minute.
A very good day to one and all. I, Ashwin Kaur, from the Department of Computer Science and Engineering, National Institute of Technology, Tiruchirappalli, is presenting my paper titled SVRCA, an approach for semantically driven video recommendation, incorporating collective intelligence. The co-author and the mentor for my paper is Dr. Gerard Deeper, Assistant Professor, Manipal Institute of Technology, Bangalore, Manipal Academy of Higher Education, Manipal, India. Abstract. In the modern era, the recommendation of educational resources, specifically in the form of videos, is an equal task. This paper proposes an SPRCA framework for education video recommendation. It is a query-centric knowledge-driven paradigm where the query terms are indexed by loading knowledge graphs from Google's Knowledge Graph API and subjecting it to structural topic modeling or aggregating relevant topics. The education videos are recommended based on categories or the annotations appended to the videos in the dataset. The dataset is classified using a solid deep learning GRE classifier and the logistic regression feature control machine learning classifier. Cosine similarity, video semantic similarity, and concept similarity are the three semantic similarity measures encompassed with differential thresholds for data point selection. As a result, SVRCA achieves the best-in-class accuracy of 96.23%, making it an efficient and semantically compliant system for the recommendation of educational videos. Motivation. The absence of knowledge-centric frameworks for video recommendation requires frameworks, models, techniques, and paradigms for video recommendation, which incorporates and encompasses knowledge-centric frameworks for recommending videos. With the structure of the World Wide Web moving towards Web 3.0, a knowledge-centric video recommendation framework is required to scope the cohesive semantic structure of Web 3.0. Contribution. The major contributions for this work include using the concept similarity. The recommendation of videos in the form of educational resources is achieved through query enrichment by Google's Knowledge Graph API, structural topic modeling, and ontology alignment with domain-centric education ontology. Heterogeneous classifications are achieved by classifying the dataset using two distinct variation classifiers: a powerful auto-handcrafted feature-driven deep learning GRE classifier and a feature-controlled machine learning logistic regression classifier. Semantic similarity computation using the cosine beta semantic similarity with differential thresholds and amalgamation of concept similarity into the model to rank and recommend and choose the best-in-class results. In the proposed methodology, as compared to the baseline models, precision, recall, F-measure, accuracy, and the NDCG values are raised, while the FPR value is decreased. Literature survey. Although several papers were used for literature survey, four important papers have been discussed. Yan et al. Have proposed a video recommendation model with auto-encoding and convolutional text networks to solve the sparsity and the coastal recommendation problem by binding the auxiliary data of users' clicking behavior. Lee et al. Have proposed a video recommendation system using big data clustering and exact inference, which is schema-driven, and the big data cluster is used to add data. Richard et al. Have proposed a fuzzy-based ranking system that considers video creation time, total watch time, video length, etc. Sentiment analysis was used to understand the domain. TU et al. Have developed a knowledge graph collaborative filtering model, which makes recommendations based on the confidence of the multipath relationship and merges the recommendation results with the user and item-based collaborative filtering recommendation results. The major gaps identified in the framework include absence of strong relevance computation mechanisms, absence of knowledge derivation reasoning, lack of auxiliary knowledge addition, and the lack of semantically inclined frameworks for Web 3.0. Proposed architecture. The user query undergoes pre-processing that comprises stopword removal, lemmatization, tokenization, and named entity recognition. The individual query terms obtained is passed into the Google's Knowledge Graph API. The Google's Knowledge Graph API promotes the individual subgraphs relevant to the query term.
The video is paused.
Either of these two classifiers are used to compute semantic similarity using cosine similarity and beta semantic similarity. All the matching classes and instances, either from these two are used to compute the semantic similarity using the concept similarity between the initially yielded entities from the very high outcomes of semantic similarity pipeline. Finally, the videos are ranked in the increasing order of recommendations based on visual features extracted with deep learning dataset. Global online learning video viewership reach 2021 by region dataset. Panoramic video and education systematic literature review from 2011 to 2021 dataset. Dataset for instructor use of educational streaming video resources and the collection of documents on the digitization of higher education and research, 1998 to 2020. These datasets were integrated into a single large dataset. The proposed SVRCA using Google's Collaborative IDE in an Intel Core i7 computer with a RAM of 32 GB and a clock speed of 3.6 GHz. Python's NLTK framework was employed for carrying out the language processing task. Google's knowledge bases were used either by encompassing the API directly or by means of Sparkle coding. Result analysis. Precision, recall, accuracy, F-measure, false discovery rate, and the normalized discovery cumulative gain are the major measures which are used for the comparison of the proposed SBRCA's performance in relation to other approaches. When compared to the baseline models, DE and VR, the highest accuracy of 96.23%, the highest F measure of 96.23%, with the lowest FDR of 0.04, and the highest normalized discount cumulative gain of 0.99. The precision, recall, accuracy, and F measure compares the relevance of the results, whereas the FDR computes the number of false positives needed by the training. The normalized discount cumulative gain quantifies the diversity of the results. The reason why the proposed SVRCA models performs the best is because it is a model-centric semantically inclined framework wherein the query is sequentially and strategically enriched using entity enrichment through the Google's Knowledge Graph API, structural topic modeling, and ontology arrangement. Furthermore, differential classification of the dataset based on GRU and the holistic regression classifier increases the heterogeneity of the results, and robust relevance computation mechanisms like the cosine similarity, TSS, and concept similarity ensures that the suggested SVRCA performs better than the baseline models. The reason why the DEMBR doesn't perform as expected is because the surplus amount of knowledge without relevancy factoring or relevancy controlling is fed into a deep learning model, resulting in an overfitting problem. In DBREB, there is an absence of knowledge derivation reasoning, learning methods, and strong relevance computation mechanisms. In FLPR, there is a lack of appropriate scaling methods and auxiliary knowledge addition due to approximate computation mechanism. In BRKGCL, there is an absence of regulatory mechanism for the auxiliary knowledge and learning mechanism to feed in the auxiliary knowledge. Performance analysis. This figure shows the precision percentage versus the number of recommendations over a range of 10 to 50 recommendations for the SVRCA and the other baseline models. It can be clearly seen that the SVRCA is the highest precision percentage for this range of recommendations. This figure shows the recall percentage versus the number of recommendations over a range of 10 to 50 recommendations for SVRCA and the other baseline models. And here too, SVRCA produces the best performance. The SVRCA model for recommending educational videos has been proposed in this paper. It is an ontology-driven framework for which the ontology alignment encompassing the concept similarity has been achieved along with structural topic modeling and loading knowledge graphs from Google's Knowledge Graph API. for enriching the query results. The SVRCI integrates two different classifiers for classifying the dataset individually and independently by using the deep learning driven GRUs and the feature control holistic regression classifier to achieve variational heterogeneity in the classification of results and have variational perspective in classification. Semantic similarity is computed using cosine similarity, meta-semantic similarity, and concept similarity with differential thresholds and several levels and stages to match classes and instances and recommend educational videos to the user. The proposed SVRCA framework achieved an overall average recall of 96.81% with an FTR of 0.04 and an MDCG of 0.99. The references used for the paper. Finally, I would like to thank everyone for providing me this opportunity to present my paper.
Yes, Dr. Jain, are you there?
Yes, I am there. Yes, are presenters there? Presenters, are you there? Or it was
Paper ID 206. No. He has submitted recorded video.
Then I think we should move to the presenter.
Yes, so last presenter is absent right now. You can conclude this session, Dr. Jain.
So it was, I believe it was a really a nice start for your conference. And hello.
Yes, we can hear you.
I think this was the last one. That's what you shared, isn't it?
Yes.
Fourth one is not available.
Not available.
Yeah. So we had three presentations in this technical session. The first one was one true pairing, evaluating effective language pairings for fake news detection, which was very well presented. And although audience wanted to ask so many questions, I stopped because I think we will be delayed. Another presentation was on a approach for semantically or towards a semantic rigorous interpretable artificial immune system for intrusion detection. And we are sorry to the audience for some technical glitch and we could not see the presentation. The third one was again equally interesting. That was an approach for semantically driven video recommendation incorporating collective intelligence. They threw a light on Web 3.0. So from overall, I believe this was a good session and I thank Dr. Patel for inviting me to chair this session. Thank you so much.
Thank you very much, Ms. Jain.
You're not audible, sir.
I'm not audible? Oh.
Now you're audible.
Okay, thank you very much, Dr. Jain, for sparing your time for us in icSoftComp. Thank you very much. Dr. Pratya?
Yes. Good morning. Good morning. I'm there. I'm there.
Good, sir.
Can you listen to me?
Yes, we can hear you.
Yeah.
Can we start your this keynote speech?
Yeah.
Okay, just give me 1 minute. Sir, made you the presenter so you can share your screen PPT.
Yeah, let me do it. Can you see my PPT?
Yes,
Hello?
we can. Yes.
Okay, just a minute.
Turn to the presenter mode. Yes, sir, everything is fine.
Okay, good.
Just a minute.
Okay.
So I welcome you, Dr. D.K. Pratya, to this icSoftComp 2022. This Dr. Dilip Kumar Pratyar is a professor at Department of Mechanical Engineering, IIT Kharagpur. He is a founder for this soft computing lab and Center of Excellence Artificial Intelligence at IIT Kharagpur. He authored a good number of books, mainly soft computing robotics. And I welcome you, sir, on behalf of the TPC Technical Program Committee, as well as on behalf of the Charotar University of Science and Technology. I welcome you, sir.
Okay. Thank you very much.
Yes, sir.
Thank you very much for your nice introduction. I'm profoundly grateful to the organizer of this conference for giving me the opportunity to share my ideas. Now, today I'll be talking on role of soft computing in developing robotic soldier. Now, this is the structure of my talk. I'll give a brief introduction to the concept of soft computing. I'll be concentrating a little bit of robotics. And we know we have got different types of robots available. And out of all the robots, the most important one and the most difficult one to analyze and control is the humanoid robot. So I'll concentrate on how to carry out the analysis of this humanoid robot. And I'm just going to consider a 25 degrees of freedom now humanoid robot. How to carry out its kinematic analysis, dynamic analysis, the dynamic balance margin, how to determine, how to formulate as an optimization problem, and how to solve it using the principle of the soft computing. And we'll see that without using the principle of soft computing, so we cannot make a very intelligent, autonomous humanoid robot, which can be used as a robotic soldier. Now I'll start with a brief introduction to the concept of soft computing. The term soft computing, it was proposed by Professor Jade in the year 1992. And Professor Jade was the professor of one very renowned US university, University of California. And by soft computing, we mean it is a big family consisting of several nature-inspired members. Now, some of the members are evolutionary tool, some of the members are learning tool, and we'll see in soft computing how to combine this evaluation tool and the learning tool to develop some combined techniques to solve the real world problem in a very efficient way. Now, if you see the real world problem, these are very difficult. Physics is not known. We cannot find out the mathematical formulation, so we cannot solve it. And to solve this type of real world problem, we'll have to take the help of the principle of the soft computing. Now, in soft computing, the term soft has been used because here we get some acceptable soft solution. We may not get a very accurate hard solution, which we generally get in pure mathematics. So by soft computing, we mean the nature inspired combined tools, which could be a combination of evaluation and learning tools. And these tools could provide some acceptable soft solution to the real world problem. Now, if you see the literature, we know the concept of computational intelligence. And this computational intelligence is nothing but artificial intelligence using the principle of soft computing. Now, as I told, that in soft computing, we try to model artificially the concept of biological adaptation. And this biological adaptation has got two components. One is called the evolution, another is called the learning. Now, this concept of evolution and learning take place in two different time scales. Learning takes place in one's lifetime, whereas evolution takes place through a large number of generations, iterations. So during the learning, which generally takes place during one's lifetime, we take the help of optimization. And this optimization algorithm uses the principle of evolution. And if I have learned some good things, good knowledge throughout my life, I'm just going to pass it to the next generation. And if I can pass the good information to the next generation, that is going to accelerate the rate of evolution. So the learning is going to help in evolution. On the other hand, evolution is also going to help in learning. Now, this is the way these two tools help each other to solve the problem of biological adaptation. And this particular principle we copy in the artificial way in computational intelligence, that is nothing but AI using soft computing to solve very difficult real world problem in a very efficient way, in a very adaptive way. Now, let me give a very brief introduction to the evolution tools. A huge literature is available on biologically inspired optimization tool like genetic algorithm, genetic programming, evolution strategies, evolutionary programming, differential evolution, cultural algorithm, vertical swarm optimization, and colony optimization, BAT algorithm, Bonobo optimizer. We have proposed this Bonobo optimizer in the year 2019, and so on. Similarly, we have got a few learning tools in the form of artificial neural networks, fuzzy reasoning tool. And using this learning tool, we try to capture the knowledge in the form of a network so that we can learn some good habits. We can train the neural network. We can optimize the fuzzy reasoning tool so that it can solve the real world problem in a very adaptive way. Now, if you see the literature on soft computing, you'll see the tools like genetic fuzzy system, genetic neural system, neurofuzzy system, genetic neurofuzzy system, and so on. And these combined tools are going to help us to solve the real world problem in a very efficient way. Now I'm just going to very quickly enter the field of robotics and how to use the principle of soft computing to develop some adaptive humanoid robot, which could be used as a robotic soldier. Now, robots, we know, robot is an automatically controlled, reprogrammable, multifunctional machine. And in robotics, we try to copy the hand of a human being, head of a human being, heart of a human being. And this heart is nothing but the emotion. So we copy 3 H's of human being in the artificial way in robotics. And our robots will be intelligent. It has to be emotional. At the same time, it has to be autonomous. And if you see the literature on robotics, we have got different types of robots. For example, manipulator, wheel robots, multi-legged robots, tracked vehicle, drone, and others. And out of all the robots, the most difficult one to analyze and control is the humanoid robot. And if you see robotics, we have got 4 distinct modules For example, we have got kinematics, dynamics, control scheme, intelligent issues. And here, kinematics and dynamics, there is no scope of using the principle of soft computing, the principle of computational intelligence, or the principle of artificial intelligence. But in the modules like control scheme, intelligent issues, there is enough scope to use the principle of soft computing that I'm going to discuss in brief within a few minutes. Now, this intelligent robot, particularly the intelligent humanoid robot, which we are planning to use as a robotic soldier, should have efficient and fast vision systems, sensors, so that it can collect information of the environment. It should have motion planner so that it can take the decision as the situation demands. And depending on this particular motion planning, there must be gait planning also, because this is a humanoid robot. So there must be a sequence of leg movement with respect to the body movement that has to be followed. So there must be an adaptive gait planner. And of course, there must be adaptive controller. All of us we know that each of the robotic joint, there must be a DC motor, and DC motor should be supported by a controller. For example, say we can use PID controller, proportional, integral, and derivative controller. And the gain values like the KP, KI, and KD can be determined. The fixed values can be determined. But for this type of robot, the fixed values of gain may not be sufficient, and it might be required that you'll have to find out the adaptive values for this particular the gain. Okay, so we need some soft computing based controller for this particular the robot. Now here this schematic view shows a very simple 7 degrees of freedom biped robot, which we analyzed in the year 2007. So might be we were the first to carry out the dynamic analysis of a biped robot, and we published this particular paper in 2007. After that, I got one Indo-Canadian Sastry Fellowship project, and there we carried out this dynamic analysis for a robot, humanoid robot, having 29 degrees of freedom. Now, after the successful completion of that particular project, we concentrated now on this 25 degrees of freedom, now humanoid robot. And in our Center for Robotics, we have purchased this particular robot and we are carrying out analysis, control, and how to make it more intelligent, that type of task. Now, as I told, that if I want to use the humanoid robot as a robotic soldier, which is a very difficult task. So what you'll have to do is I'll have to have some provision for collecting information of the environment. We can use camera, we can use sensor. There could be multi-sensor data fusion also. And once you have got the information of the environment, now we can go for the motion planning to determine the course of action during this particular your operation. Now, once you've got that particular the motion, the course of action, we'll have to concentrate on the gait planning to decide the sequence of legs movement of a humanoid robot by coordinating with its body movement. And once you've got this particular gait planning, ultimately we'll have to incorporate that particular motion with the help of your DC motor, and there must be suitable controller, adaptive controller. So we should have an adaptive control scheme. And let us see how to develop all such things using the principle of the soft computing. Now, if you see The walking cycle of a humanoid robot, it consists of two single support phases and two double support phases. So one walking cycle consists of two single support phases and two double support phases, and in between one single support phase and one double support phase, there must be transition phase for a shorter duration. Now here in this particular figure, I'm just going to show half of a particular cycle, which consists of, say this is a single support phase. The left foot is on the ground, the right foot is in air. Okay. Now B shows actually one contact phase. So this is the left and the right. These are in contact with the ground. And here you can see that C is nothing but a double support phase and D indicates a takeoff phase. So this is actually a half cycle, half of the walking cycle. And as I told, one walking cycle consists of two single support phases and two double support phases. And remember, a humanoid robot is dynamically stable. Now, we human beings, we are always dynamically stable, even if we are standing at a particular location. You forget about running, walking. During the running and walking, one humanoid robot has to be dynamically stable. There is no doubt in it. But even while standing at a particular location, the humanoid robot has to be dynamically stable only. Now, mathematically, how to ensure that the robot is dynamically stable during the single support phase as well as the double support phase. So this is a mathematical way of determining the dynamic balance margin of a particular the robot. Now, supposing that this is actually a ground foot during the single support phase. That means this particular foot is in touch with the ground. And how to determine the ZMP, that is the zero moment point, that is a point about which the sum of all the moments becomes equal to zero. So ZMP is a point about which the sum of all the moments will become equal to zero. Now there must be some force. Force will create some moment. There could be some concentrated moments also. And we try to find out a point about which the sum of all the moments becomes equal to zero. Now, if this is the ZMP, this is the point through which the ground reaction force will work. And the distance between this particular ZMP from the edge of that particular foot. So this is nothing but is your dynamic balance margin. Okay, so this dynamic balance margin has to be as maximum as possible to maintain the dynamic balance during walking or standing. Now, whatever I told, so mathematically it can be represented like this. That is XZMP is a point about which the sum of all the moments becomes equal to zero. Now let us see how to carry out the kinematic dynamic balance margin analysis of a 25 degrees of freedom now robot. Now, as so much time is not there, very quickly I'll pass and I'll try to establish the need of soft computing to develop robotic soldier. That is nothing but a humanoid robot. Now, this is the way we try to carry out the kinematic analysis. And as time is short, I'm not going to discuss in detail. The purpose of this particular kinematic analysis is to assign the coordinate system at each of the robotic joint so that we can carry out the kinematic analysis. Kinematic analysis, we know, is nothing but the analysis related to the movement of the joints the movement of the links, but it does not try to find out the reason behind that particular movement. That is nothing but a force if it is a linear joint, and that is nothing but a torque if it is a rotary joint. And after carrying out this particular kinematic analysis, so what we do is we try to concentrate on the dynamic analysis. So in dynamic analysis, as I told, we try to find out the torque if it is a rotary joint, the force if it is a linear joint. And this is actually the formulation using Lagrange-Euler. So using this Lagrange-Euler formulation, I can find out the expression for this particular the joint torque. And this particular joint torque depends on the inertia matrix, that is DIC, and QC double dot is nothing but the angular acceleration. Then comes your, it should have some Coriolis and centrifugal force that is denoted by HICD. And these are all angular velocity component. And CI, hello, hello, can you hear me? Hello, hello, am I audible?
Yes, sir, you are audible. Please
Yes,
continue.
yes, we are hearing you. We are hearing you.
Okay.
We are hearing
Okay.
you.
Okay. Now this particular CI is nothing but actually the gravity components. It depends on the acceleration due to gravity. And as I told that in kinematics and dynamics, there is no scope of using the principle of the soft computing, the computational intelligence and the artificial intelligence. Okay, now what to use that I've already mentioned, and once again I'll be concentrating on that. This is how to carry out the dynamic analysis considering the single support phase. You can see that whatever I discuss, so this particular thing, this foot is on ground and this particular foot is in air, and in the air it is following a particular trajectory. And how to maintain the dynamic balance using the ZMP that I have already mentioned. And here you can see I've written R, means it is a ground reaction force. So ZMP is a point through which the ground reaction force will work. And due to this ground reaction force, we human beings, we can stand on the ground, we can walk on the ground, we can run on the ground. It is due to this particular the reaction force. Okay. So this is what happens during a single support phase. Now, once again, I have discussed in much more detail whatever I discussed, like how to determine X ZMP, that is the zero moment point along the X direction, that is the direction of the movement, and your zero moment point along the direction perpendicular to X. Okay, so X and Y. So we can find out the expression for X ZMP and Y ZMP. Now this is actually how to carry out the analysis during the double support phase. Now carrying out the analysis during the double support phase is much more difficult, and getting a closed form solution is very difficult. So what I do, briefly, I'm just going to tell you. So we carried out the analysis for this double support phase as it the whole load, the forces distributed on the the left leg and the right foot, left foot and the right foot. We carried out exactly in the same way, the way we carried out the analysis for single support phase. Then we try to combine what could be the dynamic balance margin for the whole system during the double support phase. So this is in short how to carry out the dynamic analysis during the double support phase. You can see that, say it has got two legs on the ground. So this is one leg, one foot, this is another foot, and how to carry out the analysis. So we can find out exactly the similar way we can find out the system ZMP. Now, why I'm telling this dynamic balance is a must. Whenever a humanoid robot is working as a soldier in the rough terrain, its dynamic balance has to be maintained. That is a must. And there will be some ups and downs of the ground and in a very adaptive way. So this particular humanoid robot should be able to maintain its dynamic balance by consuming the minimum energy. How to determine the energy? Energy is determined using this particular expression. So this is actually the power or the energy you can find out. OK, so our aim is to minimize the power. At the same time, your dynamic balance margin has to be maximum. So this is the way we can formulate as a two objective optimization. The aim is to minimize the power and at the same time to maximum the dynamic balance margin. And that is expressed in terms of 1 divided by your dynamic balance margin that I want to minimize. So both the objectives are minimization. I'll have to minimize power. I'll have to minimize 1 divided by XZMP. So I can find out the Pareto front of solution also. So I can find out. So this is objective 1 and this is a objective say 2. I can find out the Pareto front of solution. OK, so I'm not going for that. We have already done it. OK, now let me tell you how to use the principle of your soft computing to solve this type of problem. As I told, we'll have to collect information of the environment using camera, using sensor. We'll have to consider the multi-sensor data fusion also. OK, to collect information of the environment. So there is no way out, but you'll have to use the principle of soft computing to collect information of the environment. And once you've got this particular information of the environment, we can go for the motion planning, gate planning, and we can think of how to develop the adaptive controller. These are some of our international journal papers which we have already published, and there are a few others also related to how to collect information of the environment with the help of camera, with the help of sensor, and how to carry out the multi-sensor data fusion. Now, this is a set of papers we have published in international journal related to how to determine the adaptive gates for the humanoid robot, the biped robot. OK. And this is how to develop the adaptive your controller for the motor mounted at each of the robotic joint. Now this motor is going to develop so this particular the joint top. And here I'm just going to show you how to determine so this particular torque. How does a motor generates the torque with the help of a controller, as the controller is having the gain value like Kp, Ki and Kd, and how to determine the adaptive values for these particular the gains. OK, so as time is very short, I'm just going to tell you in short. So this is actually the control algorithm and the PID controller, and the motor is going to work on this particular mechanical load. It will generate theta and theta dot, angular displacement and angular velocity, and it will be returned for the purpose of comparison. Theta is compared with theta d, that is the desired theta, to find out error. Theta dot is compared with theta d dot to find out E dot, rate of change of error. Accordingly, I can find out this tau prime is nothing but theta d double dot plus Kp into E error plus Ki integration E dt plus Kd into E dot. So this is the way we can develop the adaptive controller for this particular the robot. Now with this, let me come to the conclusion. Like here, the humanoid robot should be able to perform its task by consuming minimum energy after maintaining dynamic balance margin. And we'll have to improve the controllability. We'll have to increase the robustness, and definitely we'll have to reduce the uncertainty while negotiating rough terrain in the real field by the robotic soldier. Okay, and the humanoid robots should be equipped with various efficient tools like cameras, sensors for collecting information of the environment. There must be adaptive motion planner, adaptive gain planner, adaptive controller, so that the humanoid robot can negotiate that particular rough terrain in the real field. Okay, so the robotic soldier developed in the form of a humanoid robot will have to negotiate varying terrains after satisfying the above requirement. An AI-based robotic soldier is not too far. Okay, so we can use the principle of AI, the principle of computational intelligence, or the principle of soft computing to develop the adaptive robotic soldier that is nothing but a humanoid robot. Of course, there is a scope of further study. For example, we'll have to concentrate more on multi-body dynamics modeling of humanoid robot. We'll have to concentrate more on nonlinear dynamics, inverse control, model reference control, model predictive control. Also, we can think of fuzzy sliding mode control is another way of tackling the problem, and reinforcement learning based deep neural network is another tool which could be of much help to design and develop this type of adaptive humanoid robot as a robotic soldier. Yes, these are some of the books which I've written. Soft computing, uh, soft computing, its Chinese version. Robotics textbook I have written. I'm basically a mechanical engineer, so I've co-authored a book on analytical engineering mechanics. And there are some edited book and references like your research monograph based on the PhD thesis guided, some of the PhD thesis guided by me. Uh, so with this, I conclude my talk. Thank you. Thank you very much for your patience. And if you have any quick query sort of thing, I'll try my level best, clear it. Thank you. Thank you very much. So I'm coming out of the PPT mode.
Thank you, sir. Yes, sir. Audience, any questions if you have? Anyone? Yes.
Hello.
Yes. Yes.
Hello, just a minute. It seems I'm connected. Yes. Yes.
Hello.
Please.
Is it audible, sir?
Yeah, yes. I'm audible. Audible.
This is Dr. Iqbal Rashid. Actually, yes. I have one question related to your presentation. How AI is useful in mechanical engineering as well as in computer science engineering?
As I told, that in mechanical engineering, particularly in the field of kinematics and dynamics, there is no much scope of using this particular AI. Okay, but AI will be too much helpful to develop the adaptive motion planner controller, as I told. For example, if you want to make the robot intelligent, autonomous, and emotional, okay, we'll have to take the help of AI. There is no way out. Okay, same is true in the field of electrical engineering, adaptive controller for the DC motors. There is no way out, but you'll have to use the principle of AI. Okay, so in the field of your electrical engineering, electronics, and computer science, okay, related to what, there is no way out, but you'll have to use the principle of AI. But as I told, in kinematics, dynamics, those are all well searched, And these can be modeled mathematically very accurately. There is not much scope of using AI in mechanical engineering, pure mechanical engineering related to the problem. Okay, there is a little bit of chance. For example, if you consider the multi-body dynamics, which I talked about, okay, which is not properly used, I should say, or its potential is not actually exercised, okay, particularly in the field of robotics. We have done it for a six-legged robot. Now, if you just see one of the research monograph which I showed, that is on multi-body dynamics of a six-legged robot. But remember, modeling and controlling one six-legged robot is much more easier compared to a humanoid robot. And humanoid robot is the most difficult one to analyze and to control. And if you want to do it, definitely even in dynamics, there could be a few places we can take the help of AI. And nowadays, there is another trend. So directly from the dynamics, we are going to develop the control algorithm. For example, say inverse dynamics control, as I told in the scope for feature study, there could be a chance where we can inject the principle of AI even in dynamics. Okay, but in kinematics, there is no scope. It is too much structure, mathematically formulated. There is no uncertainty, nothing. So there we cannot use the principle of AI. Okay, so I hope I'm able to give you at least some the reply to your query. Am I audible to all of you?
Yes,
Yes.
yes, sir. Yes, sir. Yes. Thank you, sir. Thank you.
Can I request you one thing? Can I take one picture where some of you at least will be visible?
Yes.
Yeah, please.
I request attendee to turn on your camera.
Yeah, please. This will be a good memory.
From audience.
Yes.
Dr. Kavesgar, you have a question or a query?
Yeah. Please, if you have anything, I'll definitely try my level.
Dr. Pratihar, maybe I first take your picture and then we discuss.
Oh, yes.
Sir, please turn on your camera, sir.
My camera is on. My camera is on. Only thing.
We can see your presentation, PPT.
Just a minute. Now, can you see me?
It's a bit dark, but it's.
Yeah, actually, is light is not proper, it seems. But is it not visible?
It is.
Yeah.
Doctor, maybe you don't hold the camera in front of your face.
Yes.
Yeah. That is the thing, actually. Then.
And sir, one more thing, you just unshare your presentation.
Presentation, I'll have to make the PDF file and then I'll share it to you. Okay. I'll be sending, might be by evening I'll be sending, because now I have got another meeting. I'll have to go for that.
No problem, but sir, right, you just unshare your presentation slide.
Acha, just a minute.
So that
just a minute. Yes.
Yes, sir. Now
yes.
You are. Yes, Dr. Kavesgar.
Yeah. Actually, once again, my face will be, I think, not visible, it seems.
Sir, I will provide you screenshot.
Please send me one to my email. Okay.
Yes, sir. Yes, sir.
Okay. I really enjoyed. So
sir, one
if you have
question.
Dr.
Please, please.
Pratihar, may I ask a short question, please?
Yeah, definitely. You're welcome. Very much.
Thank you so much for your presentation. It was very interesting, and we share some common interest, in fact. I would like to know, I saw that new robot that you have. I just would like to know that if you have tried on practice the control model which you showed. The only concern that I have, the question that I have, if you have tried it, did that network where you are passing the error to your theta, to your tau, in fact, did it cause any lag?
Yes,
It caused some lag, right?
Yes, you are right.
Yes, and what do you suggest if we want to use such a thing? Which one was the fastest way? You know, which algorithm or method?
Yeah, actually what we do is this particular lag we cannot avoid. So whenever we do sampling of the time, okay, so we'll have to do this particular sampling in a very adaptive way so that we can minimize this particular lag. Lag will be there, you cannot avoid. So what you'll have to do is little bit of error and trial is required. Like what I'm telling, the total duration is divided into a large number of small segments. Now, what could be the duration of each segment so that I can minimize this particular lag? So a little bit of error and trial is required during implementation. So there is no predetermined solution to that. So you'll have to tune little bit. I hope I'm
yes. I just want to I wanted to know that if you agree with me that this lag will be there. And my second question is a bit philosophical. If you want, we can discuss it later offline. You named your robot soldier robot, and then you brought heart and emotions and algorithms to bring these emotions. And I don't know how this has to be done. If you think this is not a right place for it, later we can discuss this.
No, I can tell you in short, very short. Okay. For example, say we human being, we are intelligent. At the same time, we are emotional. So any decision taken by us cannot be 100% intelligent. It cannot be 100% emotional. Let me take a very simple example. For example, say in my course, so one student has got 34 out of 100. Okay, and 35 is the pass mark. Are you getting my point?
Yes.
So if I'm 100% intelligent, I should not allow that particular student to pass. Are you getting my point?
Yes.
If I'm 100% emotional, even if he got 35, I'll be giving EX, excellent grade, if I'm 100% emotional. So what we do is we take the decision. It is a combination of intelligence and emotion. Somehow we make 34 to 35, give him pass mark, P grade. Okay. So we human being, our decision is a combination of intelligence and emotion. The soldier who is walking in the field, don't think that he is not a human being. He is also a human being. So any decision taken by him could be a proper balance between intelligence and emotion. So the robotic soldier, if you make 100% intelligent, not emotional, it is not the right way of doing. So the soldier cannot be 100% intelligent or 100% emotional. There must be a proper balance between emotion and intelligence. This is the point which I want to make. Okay.
Thank you. Thank you.
Thank you. Thank you very much.
Thank you very much, Dr. Pratihar, for spending your valuable time for us and coming here and giving very informative and very knowledgeable like this session, this keynote speech. Thank you very much, sir.
Thank you very much. I also really enjoyed and learned a lot. Thank you. Thank you very much. So I'm coming out of the meeting.
Yes,
okay?
Sir. Yes.
Okay. Thank you.
Okay, our next keynote speech is by Dr. Witold Pendrikes. He is from Faculty of Engineering, Electrical and Computer Engineering, University of Alberta, Canada. His area of research is computational intelligence, then bioinformatics and granular computing. Also, he is interested in intelligent and human-centered system. He has submitted as the pre-recorded keynote speech. So I just play it. Give me 1 minute.
Robert? I'm going to welcome everybody to this talk. And first of all, I'd like to express my thanks to the organizers for giving me this opportunity. And also, I'd like to congratulate them on the timely and important.
Has audio and video properly? Are you getting?
The voice is not very audible, Dr. Patel.
Thank you.
Event, I know how much time, how much energy goes into the organization of the conference. So I think the organizers really deserve our thanks and gratitude. Today, I'd like to talk about a certain direction that you can see in machine learning. And I call this a society-oriented environment of machine learning. Because when we are seeing today's progress of machine learning or artificial intelligence, we also see that there are some looming problems, or there are some implications of high societal value. So here's an abstract breakdown of my talk. I would like to really start with some setting of the stage and looking at machine learning, what the main directions are, what the key accomplishments are, and what are the challenges ahead of us. And then move on to this society-oriented quest. Obviously, the talk is not exhaustive in the sense that I did not cover all possible directions, but I'd like to highlight a couple of them, which in my opinion are very essential.
Audience, please, are you getting audio with video?
No, sir.
No, just video.
Just a wait, then.
This time of this day could be temporary visible.
Are you getting now?
So it's
Yes.
Yes.
Okay, thank you.
I think the two of them that are visible just quite profoundly is and I will bring artificial intelligence. I prefer to use it from brain. So learning, assuming essentially that AI to
Sir, his audio is not audible, sir.
and
I think that
Audio is not audible, clear.
right.
highlight and identify that all of
Let me see. Just a minute.
grammars is a certain different tool deliver a kind of proper way of abstraction onto problems. And here we are. Society of machine learning, the problems that we encounter, but also some solutions. Obviously, my talk is
Are you
not
getting now?
really able to cover everything, so given the amount of time, I would like to sort of provide some highlights and look at the essence as well as identify eventually some technicalities that were introduced.
Still, it is not audible. It's clear audible, sir. It's still not clear audible.
But are you getting some sound, audio?
Yeah. Sound is coming. No problem. But voice is not clear. Voice is not clear.
Okay.
I mentioned the witnessing at tremendous computing overhead, which obviously has some societal implications and obviously comes with very hefty energy bill. It is frustrating that we are doing this deep learning
Sir, no sound. No sound is coming, sir.
Yes, there is some technical issue. I think we'll play this video later. I stop this video right now. Just a minute. We can have his keynote speech later. Sorry for inconvenience to all of you. Am I audible now?
Yes, Ratibati.
Yes, sir. Yes, sir. So
Yes,
I think
sir, you are audible.
we can start the next technical session. That is a technical session S2. Dr. Kumar, are you there? Vikram Kumar? Just give me 1 minute. Okay. So any author from technical session S2 are there? Are present over here? Paper ID 232 044 106 and 092. If you want to present your paper right now, just let me know. I can make you the presenter. We'll start in a few minutes session, technical session S2. There are 4 papers in this technical session S2. Paper 044 is submitted, author of paper 44 is submitted the pre-recorded video. So I will start the paper pre-recorded video of paper ID 044.
Hello everyone, thank you for having me here. Today I'm here to present our paper, Association Rules-Based Feature Extraction.
Are you all getting audio now?
Yes.
Yes, sir.
Thank you.
For deep learning classification. The outline for this presentation is the introduction, the motivation for our paper, the contribution of our research, and then a literature review of previous papers that utilize association rules with deep learning models. Then we will go through the methodology that we adopted, the results, and the conclusion. So the purpose of feature extraction is to represent each data object with a small but effective number of features, and that would improve the efficiency of the classifier because datasets sometimes have a lot of features and some of them are not necessary. So we remove the features that are not representative of the data object, and with that we improve the accuracy of the classification. There are three approaches of feature selection methods: the filter approach, the embedded approach, and the rubber approach. For the filter approach, we select features based on some generic matrix such as correlation coefficient or information gain. Also, our method is a filter approach because we select the features based on association rules. The embedded approach selects the representative features during the training of a predictive model, and an example of the embedded approach is the decision trees. After that, the wrapper, where the feature selection process is wrapped around the classifier, for example, the genetic algorithms. The motivation for our research is that the number of extracted features from medical data has been known to be large and affects the performance of the use specifiers. Because datasets from medical data, especially, have a lot of features compared to the number of samples. This number of samples will be very few, and the number of features will be very large. And that would really decrease the accuracy and the performance of the classification. And also, another motivation is that the existing feature selection methods reduce the feature space into smaller ones, but also reduce the classification accuracy. So we want to achieve a methodology where we enhance the accuracy and reduce the feature space. Have our contribution where we utilize the association rules to select features from medical data, and we reduce the dimensionality of the input feature space using the filter approach. After that, we evaluate the effect of association rule-based feature extraction on the ResNet deep learning model. Some papers already use association rules with deep learning models. The two main approaches for using association rules to benefit deep learning models is the feature extraction and the analysis of the classifier results. So the first two papers use the association rules as feature extractions for selecting the attributes before entering them into a deep learning model. The first paper used the priori algorithm, and the second one used the genetic algorithm. For the second two papers, they used the association rules to provide some reasoning of the classifier results, because the decision of deep learning models are a black box where we don't understand what's going on. So to trust the models more, we need some explanation about the results. And they use FP crows and Bayesian rule induction method to extract the association rules. So there are two, in our methodology, we use two association rules based on a priori algorithm. There are AR1 and AR2. In AR1, we extracted the association rules among all input parameters, and then the feature in the consequent part of the rules is eliminated because these features are already represented in other features, and we have to prevent multicollinearity. In AR2, we find the large item sets for each client class. These item sets, and we use them as input features. So in AR1, we only reduce what we found, and AR2 we only use what we found. So after we extract the association rules, we inputted them into a ResNet model, and here is an illustration of our approach. The datasets that we use is the dermatology dataset and the breast cancer Wisconsin diagnostic dataset. For the first dataset, we have 34 input features with 6 target classes and 366 instances. And the second dataset, we have 31 attributes with 2 target classes and for the results, we use because it's more accurate than the simple training testing split. And the ResNet model is constructed with 4 other machine learning algorithms. These are the multi-layer perceptron, the k-near snapper, and the random forest classifier, finally the support vector machines, where we report the mean and the standard deviation of 20 runs for each algorithm. We use 20 runs to provide more reliable results. And then each algorithm of these will be assessed with all the inputs, with the inputs reduced with R1, with the inputs reduced with R2, with the inputs reduced with R1 and R2, and each of the results is reported. So for the breast cancer dataset, we found that the area standard error, which is the fifth feature, is highly correlated with other attributes. Thus, we removed it using the AR1. And then for AR2, we found the frequency for the malignant and the benign classes, and we combined them to find 24 necessary attributes, and we reduced all other attributes. So when we use AR2, we use 24 attributes out of the 31. When we use the AR1, we use 30 because we only remove the first attribute. And when we use AR1 with AR2, we use 23 because we also remove the first attribute from the reduced features. So here's the results, the final results of the 5 classifiers. We found that the ResNet has really the accuracy of the ResNet has improved with the reduced features comparing to using all the features. And in the dermatology dataset, we found that the 27th attribute is also correlated with other attributes, so we removed it. And we found the frequent item set from AR2 for each of the 6 classes, and we combined them all together to find 25 attributes from AR2, 24 from AR2 and AR1, and 33 with AR1 only. And here they are recorded. So also in the dermatology dataset, we can see that we have the highest accuracy with AR1 and AR2 reducing feature with only 24 attributes compared to using all the attributes which are 34. And we have almost 1% enhancement in the result. So in this presentation, we presented a classification model that leverages association rules to select reduced set of representative features. And then we fed these into the ResNet, which is a deep learning classifier. And as we show in the experiments, the reduction method improved the results, and the ResNet have good results compared to other classifiers. Thank you very much. These are the references of the papers that we already discussed. And if you have any question, please ask.
From audience, if you have any question, you can send email to me, or you can type in a chat box. I will forward it to the author. So next paper is with a paper ID 106. Author of paper ID 106, are you there?
Yes, sir, I'm here.
What's your name?
Abhirami Gunasekharan.
Just a minute. I'm making you the presenter.
Yeah.
1 minute. So now you are presenter. You can start your PPT and you can share your screen.
Thank you, sir.
You have 10 minutes to complete your presentation. Then that followed by 4 to 5 minutes of question answer.
Thank you, sir. Sir, can you see the screen?
We can see your camera video, but cannot see the PPT.
Sir, is it visible now?
Yes. Just yes.
Thank you so much. Shall I proceed, sir?
Yes, you may start.
Yeah, thank you. Good afternoon to all. I would like to present my work, Method Agnostic Model plus Reliance Explanation of Multiple Machine Learning Models. This is my outline of my presentation. We could see the increased implementations of AI and machine learning systems in all the fields because they could contribute the human to take their decisions in their day-to-day life activities to complex business decisions. Though they are highly accurate in making the predictions, the reasons behind that decisions are hard to understand. For example, for a machine learning model, we are giving the input and it gives the predictions, but it does not convey why and how it has arrived at decisions. This logic abstraction makes the model as black box and also creates legal and ethical problems. To create the trust and to accept the decisions of the model, the research field called explainable AI is promoted. Under the XAI umbrella, there are a lot of methods are proposed to provide the insight into the black box model. Among them, feature importance gets greater attention. This provides explanation in the form of features contribution towards the model's prediction. When do we need the explainability of the model? We train a model and we observe that it is a black box. So to get some insight, we apply the explainability method on the model's decision to get the explanation behind it. Since we can avail multiple methods, we can try with multiple explanation methods to get the explanation. Surprisingly, we are getting the different explanation for the same model. As per no free lunch theorem, a single model cannot be perfect in all the domains. So multiple models can be trained by us with similar accuracy, and explanation method can be applied on those models. Finally, we end up with multiple models and multiple explanations. If we choose any one of these models, sir?
Your presentation, like you are in a first screen only. First slide.
It's not getting moved.
No. We can see your first slide only.
Oh, okay, sir.
Please go to the next slide so that we can.
Um, sir, are you seeing the slide with the existing explainability approaches title?
Oh, first slide. Title.
Only the first slide.
Yes.
Oh. It's weird.
Have you shared the? Yes. Now it's a third slide. Introduction.
Okay. Okay, so from here I am.
Okay, no problem. Yes, now it's on a fourth slide, existing EA.
Okay. Yeah, yes, sir. So when do we need a model explainability? We train a model and we observe that it is a black box, and to get some insight, we apply the explainability method on it to get some explanation. Since we can avail multiple methods, we can apply with multiple methods to get different explanations. Surprisingly, the method explanations are different even for a same model. As per no free lunch theorem, a single model cannot be perfect in all the domains. So we can train multiple models for the on the same data set, and we can apply the explainability methods. And finally, we end up with multiple models and multiple explanations. If we choose any one of these models and the explanation method to provide the explanation behind the model's decision, then obviously the explanation will be biased over the model and method. So this is the problem identified in the existing literature. There is no standard guideline to suggest which explanation should be trusted when we get different explanations from different methods. Similarly, we do not have any reason to select from multiple similar accurate models to select one model from multiple similar accurate models. So what's the solution for this model and the method explanation multiplicity? For the model multiplicity, the concept called Rashomon set, which is introduced by Bremen in the year of 2001, can be used. Instead of training a single model and providing the explanation for that model, a class of models are trained for the data set, and the explanation is given for the entire range of models. Instead of a single value, a range of feature importance will be given. That is, the lower bound and upper bound for the feature importance value of each feature is given as a model class reliance for those model class. So this solves the model explainability multiplicity. For the method explanation multiplicity, multiple explanations are unified to provide a um, aggregated explanation out of multiple methods based on the similarity. So this provides method agnostic explanation. Combining these two concepts, the method agnostic model class reliance explanation address both the model and method explanation multiplicity problems. The framework is given here. We can select any tabular data size with the necessary pre-processing, and multiple machine learning models are trained on it. From the pool of trained machine learning models, the best model can be selected as a reference model. From the prediction accuracy of that model, a small positive value called epsilon can be reduced to extend the boundary for selecting the near optimal models. From that epsilon boundary, the set of near optimal models are selected as Rashomon set, and multiple explanation methods are applied on those models to get the explanation. By applying the Borda method, optimal explanation for each Rashomon set model is obtained. By comparing the explanations against this optimal explanation, how much similar the explanation methods could produce the explanation is identified. That similarity score is assigned to each explanation method using an algorithm called RBO. With that similarity scores, the weighted feature importance value are computed for entire Rashomon set models. From that weighted importance value, the minimum and the maximum bound of the feature importance for every feature in the data set is identified. This forms the method agnostic model class reliance value. So the effectiveness of the framework is established, demonstrated with the data set called Campus, and the descriptions are given. And in the right side, we could see the histogram of trained models. The best model is chosen with the 69%, and with the epsilon value is set to 5%. Now the epsilon threshold accuracy is set to around 65%. The models which are above the 65% are selected as a Rashomon set model. Out of 2,665 trained models, 350 models form the Rashomon set. And 6 explanation methods are selected to get the explanation for the 350 models. They all belong to feature importance category and all provide the global explanation. In that, LOFO method requires retraining and the other methods do not require any retraining. So this shows the explanations obtained from 6 explanation methods for the 350 Rashomon set models based on a race feature. We could see the variation in the feature importance allocation by the different explanation methods. This shows the explanation multiplicity among the methods. The first method concludes that almost for all the models, race is not an important feature because only 10% importance is allocated to the race feature. It is agreed by the sixth method. And from the remaining 4 methods, we could see the importance value allocation from 20% to 70%. This concludes that race has moderate to high importance in making the model's decisions for as per these methods explanations. So this provides the explanation multiplicity and the analyst may get confused which explanation has to be trusted. So this is the multiplicity is shown for the other variables of the data set also. To get the unified explanation, the MCR method then finds the optimal explanation for each of the Rashomon model, and that range is displayed here. And from this, each explanation is compared against the optimal explanation to get a similarity score. From that similarity score, the feature importance weighted mean is computed. From the range of values, each feature's importance value is identified. That range is displayed here. This demonstrates, this range describes the comprehensive feature importance of each feature. That is how much the model class depends on each feature that is shown as the range of feature importance. This not only convey this information, but also convey which feature are most important for all the models and which feature is not important for any of the model. For example, the prayer model has highest value in its lower bound. It says that prayer is important to all the models. Whereas the age feature has lowest value in the highest, its upper bound. It says that age is not important feature for all the models. To validate the coverage of this MCR range for all the epsilon threshold Rashomon set models, multiple random test models are trained, and its importance value is acquired from the different methods, and that is validated with the MCR range coverage. This diagram shows that the test model's importance is covered within the range. So this demonstrates that the MCR could cover the feature importance range for all the epsilon threshold Rashomon set models. Thus, the inconsistencies present in the explanations obtained from multiple methods for multiple models stimulated the development of a framework called MAMCR to get a unified, consistent explanation across method and model multiplicity. This range describes the comprehensive model reliance value of almost equally accurate models. So this framework addresses the method and model multiplicity problems. Thank you very much for listening to my presentation. I'm happy to answer your queries.
Any questions from audience?
Yes, sir. I have one question.
Yes, you
from
may.
Abhirani.
Yes.
Yeah, actually, you are talking about the multiple model or multiple machine learning model. So first of all, I'm struggling to understand the meaning of this, how multiple machine learning model is working. Second is which machine learning technique is applied, or which one is best?
Here for the first question, which model is working, in the sense that which machine learning model I applied for on this data set, you mean?
No, actually, you are talking about the multiple machine learning model. What it means?
It's any machine learning algorithm, for example, logistic regression, linear regression, or random forest model. So any model, any machine learning model which converts the input into output predictions.
So which one is best?
This is not going to say which machine learning model is best, but instead, if you apply multiple algorithms and if you apply the different explanation methods, the explanation will be different from each method, as I shown in the.
So you are
if I
not
apply,
comparing. You are not comparing.
yes, I am analyzing with the optimal explanation for each model. The different explanations are obtained for each model, and different explanations are compared. And based on the comparison with the optimal explanation, the consensus explanation is obtained out of a different explanation, because the first explanation suggests race is an not important feature, but the second and fourth explanation says that race is an important feature. You can see the explanation multiplicity from this slide. The first method says that explanation race feature is not at all important for almost 350 models. But if you see the fourth method, shape method, it says that race is as moderate to high importance. That is, the model depends on the race feature to make decision. If analyst uses the shape method, then explanation depends on biased on the particular method. If he applies the sage method, it says that race is not important. In that case, he gets confused which explanation has to be accepted. It should be trusted. In that case, if they use the MAMCR framework, they will get the consensus explanation out of the multiple explanation methods.
So my
That explanation
observation
will be, yes.
Yes. My observation is it's a very elementary work. Okay, thank you.
Thank you.
Anyone else has any question? Okay, thank you very much. Thank you very much, Ms. Guna Sikaram, for presenting.
Thank you, sir. Thank you for this opportunity to present my work.
Thank you. So next paper is with a paper ID 092. Author of 92, are you present here? Okay, so let me play his pre-recorded video of his paper. 92.
Greetings, everyone. Greetings, everyone. My name is Khushbu Shah, and I'm pursuing my PhD from Gujarat University. Part of my PhD research, today I'm presenting my work, which is optimizing public grievance detection accuracy through hyperparameter tuning of random forest and hybrid model. We all know about the Twitter, and also we know that many organizations, companies have their official accounts on the Twitter where they communicate with their clients and of course with the public. So here the idea is to get the social media comments that is on from the Twitter, especially for the Indian Railways, posted especially for the Indian Railways, to identify that the actual piece of code is a grievance or not. Because what happens normally, people post all the likes and dislikes, but when it comes to the complaint, when it comes to the grievance, it is really meaningful. It is really useful for any organization to identify, because only after resolving the complaint it is beneficial for the company. So Indian public normally share their experiences about the trains, their journey, and IRCTC services, Also about the railway ministries, if they have complained, then they simply post their message on the Twitter for the particular railway handle. But identifying that is it a genuine complaint or not, that is really very difficult from millions of text of pieces. So here the role of the machine learning comes into the picture. But so of course we can make it automatically. But the thing is, machine learning provides very wide range of models, supervised learning models, binary classifiers, which can help us to identify that the piece of text is a grievance or not. But the thing is, among all these wide range of supervised learning models, which one is the best for your application, for your data set? It is really a challenging task. And also we have seen that researchers have put their immense efforts to identify that which one model is really best learner and a performer for your data set. And this is the idea of this research work. So in this paper, we have mainly focused on the binary classification task. That is, when machine reads the tweet, it should be able to identify that is it a grievance or not. So it comes under the binary classification task, and this is for the Indian Railway tweets which are posted on the Twitter for specific Indian Railway handles. So the core objective of this paper is to study the prediction performance of random forest classifier. There must be a question that why only random forest classifier, because we have already done work. This is our third phase work. We have already done the work and we have found that random forest with the word embedding technique perform really well against the other 5 classifiers that are support work to machine, logistic regression, decision tree, and k-nearest neighbor. So we have already done this work in the last phase, and in this phase we are working on the random forest performance by doing the hyperparameter tuning. And also we have proposed one hybrid model. We have built one hybrid model to check that how we can use the best of all the classifiers. So this is the core objective of this paper. Framework of our core research. So here what we are doing, here we are downloading the grids, and after doing the cleaning process, we started with the phase 1, phase 2, and phase 3. This paper, particularly for this presentation, this is our phase 3 work we have already done for the phase 1 and phase 2. In the phase 1, after checking the binary classifiers and the word embedding techniques, we found that the random forest is really well. Even in the second phase, we tested different ratios of the records with various combinations, and also we found that random forest performing well. So in this third phase, we increased the records, that is 13,000 records, and we tried 3 different methods. We tried 2 different methods, sorry. One is a hyperparameter tuning, and second is the hybrid model approach. And here we are predicting the class. That class means is it a grievance or not? Piece of text is a grievance or not? And this we are predicting. So this is the complete framework of the work. So here it's a first methodology, and that is random forest hyperparameter tuning. So as I have already said that why we are using the random forest only, because it has performed really very well so far on this data set. The meaning of the hyperparameter tuning is it's actually a significant process to get optimal values of a specific parameter. And many studies have also shown that when we apply the parameter tuning, model works really well and more efficiently. It gives the results. So performance of the model is actually it depends on the tuning, how you tune the various parameters, so which type of combination you choose, and you test your model. So it is really very important while you are doing the hyperparameter tuning. In random forest there are many parameters are there. Mostly 18 parameters are there, and from out of 18 we have used all these main parameters which are actually responsible to power the prediction. Various studies have shown that normally random forests perform well with the default values. default values of the estimator parameter. So we have tested our model with all the default values along with the tuning. So we'll see it in the next slide. So here it's hyperparameter tuning results after applying the. So there are total 22 runs during the experiment. 22 runs we applied, and estimators, max depth, minimum sample split, and minimum sample lift. These 4 parameters we considered, which are actually responsible to the prediction, which are actually responsible to affect the final results of the accuracy. So as we can see here, that we started with the 100, 5, 5, and 5, and eventually, gradually, we apply the various combinations, different combinations, and we test the accuracy. So as we are moving ahead, we can see that it is actually increasing. 81, 83, 88, 87, 89, 89, and this way, and somewhere it is stagnant. Somewhere the result is stagnant. You can say 92 at run 16, and 92, 92, then 92 only. So here we can see that our result is stagnant now, but with a very minor change, 9 to 6, 9 to 7, and 9 to 4. So here it's a limitation we can see that we got during the hyperparameter tuning on the random forest. So conclusion is random forest during the hyperparameter tuning of the random forest with a 92% accuracy for this experiment. This is the graph of the same of the previous slide, where we can see that how the accuracy is increasing, and at the end we got some very good results, that is 92% accuracy in this. In the second method, we approach with the hybrid technique or a hybrid approach in the machine learning. Actually, hybrid approach says that when you have multiple models, so you can use the best of all the models, and you can combine, you can hybrid all the models, and you can make it a one, and then you can test and train and test your data on that. So this is the idea of the hybrid machine learning approach. So here we have analyzed during our experiment that each classifier actually performing well. So if we do something through which we can get the best of all the models, then definitely we can get the best result at the end. So this is the hybrid approach of the machine learning which we have applied, and very well we'll explain in the next slide. Here it's a hybrid approach and the grievance identification formula explanation. Here is the formula which we have derived after our experiments, and here is the example. So first I would like to explain this, that what we actually did with this function, and here is the example based on these values. So first we add the predicted class values from each classifier that we are doing with the sigma, and divide the sum with the total number of the classifier, that is my n, and a bias value of 0.49, that is my b, is added to the total. Why bias value? So bias value is essential when even number of binary classifiers are used, as we have one of the possible results where equal number of the classifiers determine 0 or 1. In order to break the tie, because when we have the even number of classifiers, and if 3 are saying yes and 3 are saying no, so that's a tie. And to break that tie, here we need a bias value, which so here bias value switches the activation function to get signum function of summate and results to 1 or a -1. So if the final result is 1, then given text is a grievance and it is not a grievance, which we can see from this table, that here we have the tweet ID and all the 5 binary classifiers are here, which has a prediction like first ID, SVM, RF and KNN are saying that it's a grievance, while LR and DT is saying not grievance. So 50%, more than 50% are agreed with the grievance. So our final result is 1. And here is the calculation how this function works. Like SGN function in the bracket, all the predicted values divide by 5, that is number of classifiers, and we are adding the bias values, and at the end like SGN 0.11. So SGN is just for the sign purposes. It's a positive one means it's a grievance, and if it's a negative one means it's not a grievance. So this is the idea of the hybrid approach. Here is the final scores of various models for all the 13,000 reports. So here we can see that the data decision tree, logistic regression, SVM, KNN, RF, the results, their accuracy 87, 88, 89, 91, 92. It is increasing actually because the way we have put the name of the classifiers. RF hyperparameter tuning, if you observe, so in this all the 5, RF was performing really well. Then we applied the hyperparameter tuning, so from the 0.92 we got to 0.93. But while we go with all the best of all the classifiers hybrid approach, we got to 0.96, and it is actually very good accuracy score. So this is the final results of our experiment. This slide contains the all over results of all the experiments which we done for the phase 1, phase 2, and phase 3 for this, that is this paper. So final accuracy, we can observe that how we are increasing from 0.9394, and finally we reached to the 0.96 for this experiment. So this is really remarkable score for the experiment. Here we are concluding that working on the hyperparameter tuning is really well, but when we use the best of all the classifiers, then we will definitely get the best result for our data set, for our application. And in our experiment, our final accuracy score was the 0.962 in an open environment. And the future scope is definitely will go for the other non-railway domain. We will try this set up this algorithm to that, and also we can go for the hyperparameter tuning on other classifiers, and we can check that how that works with this data set. So here is the future scope and the conclusion. I thank Gujarat University for funding this research work. I'm thankful to my guides, Mr. Hiren Joshi sir and Mr. Hardik Joshi sir, for the guidance. I'm grateful to peer reviewer who gave their expert comment on my paper, which helped me to improve my work. And thank you icSoftComp2022 for this opportunity. And here are the references which I have used in my experiment. Thank you.
Miss Sa, are you there? Khushbu Sa?
Yes, sir.
Okay. So anyone has any question, then they can ask. Anyone has any question? Okay, Miss Sa.
Okay, thank you, sir. Thank you.
So next paper is paper 232. So author of paper 232, are you there? Miss Ankita? Author of paper ID 232. Are you present here? I think author is absent here right now. So in this session, we had 3 papers. So this end of this session, second technical session has 2. So now it's a time for lunch break. We are a little bit earlier, but okay. So at 1:30 we'll meet again with for a technical session as 3. Thank you very much, everyone.